What's going on, smart people? Super quick video today. It's getting kind of late. I consider myself pretty proficient in different branches of math. I think my strongest is linear algebra and tensor analysis and maybe differential equations I feel really comfortable with. And today, after turning in my most recent homework assignment, I had thrown in my face what my weakest branch of math is, which, as it turns out, is probability and statistics of all branches of math. So this kind of makes sense that that homework assignment was for statistical mechanics. And that might sound a little bit weird. What could be so hard about probability and statistics? And from a quantum mechanical perspective, I feel really comfortable solving those kinds of probability problems. I don't know if it's a notation thing or the way it's introduced. I'm not too sure. But for some reason, when introduced in statistical mechanics, I'm not entirely comfortable with it yet. We'll be given some number of microstates, or we'll find the number of microstates, which is basically how many different configurations, like a snapshot in time, a system of particles could have. So we'll be given that, and then we'll be told to find maybe the probability or the expected value of a system or something to that effect. And I was just having a really hard time solving those kinds of problems with the different types of distributions and the combinatorics associated with it. So if the microstates were, say, a binomial distribution and finding the probabilities, it's not necessarily difficult stuff, I can tell. The reason that I'm having a hard time with it isn't because I've been beating my head against the wall, struggling with probability and statistics my entire life. It's just that I haven't put really any time into learning it since AP Prob Stat in high school, which was 6 years ago. 6 years ago already. That's insane. So it's something that I think that I could pick up relatively easily. I just need to actually put in the time to go over the statistics. Probability and statistics is obviously extremely useful in things like statistical mechanics. You know, in quantum mechanics, you want to find the expectation value. You just sandwich the operator in between your wave functions and integrate over it. It's really easy. And maybe it's the exact same thing. I'm assuming it has to for stat mech, and I'm just missing the connection between the statistical mechanics and the quantum mechanics that would make it easier for me to pick up on. So what I need to do is I need to find a good resource of probability and statistics. I need to start reading up on it, just spend a weekend going over it so that I'm not so stumped next time and it doesn't take me so long to solve these kinds of problems. Because, you know, when you're finding these probabilities, if you're given like a binomial distribution, yeah, sure, there's equations for it. There's equations for the expected value and the probability as a whole, but those are just, you know, kind of just available online, the equations. And I don't want to just say, I found this online and this is what I used. I want to be able to derive it. I want to be able to understand why it is what it is. So I don't have that intuition yet for that as I do for quantum mechanics, and that's a weak point I need to iron out, especially next time the qualifying exam comes around if there's any stat mech problems. So maybe this weekend I'll spend some time learning more. Got to turn those weak points into strong points, you know, PowerPoint. Let me know in the comment section if you have a favorite resource that you recommend, and I will see you guys there.